Okay, let's look at writing ionic compounds. I gave you a lot of practice in these because this takes a lot of practice to kind of get used to. So I figured several of you might need the second page of practice. So I went ahead and ran some of those for you. So let's look here. What we're doing is we're just writing, filling in the boxes. The first thing we're going to write the symbol. The second thing we're going to do is write the oxidation number, which is the number of electrons an atom gains or loses when chemically combining. We're going to write the molecular formula for the compound. The first one has been done for you. Hint, Roman numerals tell oxidation numbers of transition metals. So, here we go. Magnesium is a +2. Bromine is a -1. So, you're going to crisscross applesauce. Magnesium is a 1, and bromine gets the 2. Remember, you're taking the oxidation number and you're bringing them down on either side. So magnesium, again, was the +2. Bromine was the -1. So the 1 comes down here. That's why I did not put a subscript. The +2 comes down here. So when I look at the two sides of this compound, 1 times +2 is going to give me a +2 charge on that side. 2 times -1 gives me a -2. You want these to balance. Okay, let's look at sodium. Sodium has a +1, oxygen has a -2. So again, I'm just going to write this out. Sodium gets the 2, oxygen gets the 1 as a subscript. Lithium has a +1. Oxygen has a -2. It will look exactly like sodium and oxygen, combining in the same ratios because they're from the same families. All right, boron is a +3. Chlorine is a -1. So boron gets the 1, chlorine gets the 3, BCl3. Iron is a transition metal, so they had to give you its oxidation, which is +2. Iron, any transition metal, always positive. Chlorine, -1. So Fe gets the 1 and Cl gets the 2. Cobalt, +3. Nitrogen, -3. They balance. If you did the 3 and 3, you'd have to reduce that to 1 and 1. So cobalt, make sure that is capital C, little o, and then capital N for nitrogen. If you made that O big in the middle, it would look like carbon bonded to oxygen bonded to nitrogen, and that's not what we want. We want cobalt and nitrogen. Aluminum, +3. Neon, neon has an oxidation number of a 0, meaning it's not going to bond. Neon is a noble gas, so this is not going to work. It's not going to bond. Aluminum, +3. Oxygen, -2. So I'm going to get Al2O3. Nickel has a +3. Oops, I'm in the habit of doing that. +3. Hydrogen. In this case, hydrogen is so different, and I really just wish I didn't put this one on here, but that's fine. We can work with it. Hydrogen actually can be a cation, or it can be an anion. So hydrogen can have a -1 charge, or it's a +1. Again, hydrogen's so different. This is not common right here that we won't do, but hydrogen can be a +1 or a -1. So in this case, you just follow those same rules. Nickel gets the 1 and hydrogen gets the 3. All right, and you would say that is nickel hydride. All right, potassium has what is potassium? A +1. Sulfur is a -2. So potassium gets the 2, sulfur gets the 1. Sodium, Na, +1. Iodine is a -1. They balance, so you just write it NaI. Sodium, Na, +1. Oxygen, -2. Na2O. Copper, that's Cu, 2, positive. Chlorine, -1. So it will be Cu1, Cl2, copper chloride. Barium is a +2, and fluorine is a is for -1. So this would become Ba1F2. All right, next side. Over here, oxidation numbers, same thing. Potassium has a +1. Chlorine has a -1. Compound formula, potassium chloride, and that's how you would say that, potassium chloride. Li has a +1, oxygen -2. That would be Li2O, which is lithium oxide. All right, Na has a +1, sulfur has a -2. So I'm going to end up with Na2S, sodium sulfide. Aluminum, +3, fluorine, -1. So I'm going to end up with Al1F3, aluminum fluoride. Now remember, because these are ionics, we do not name the subscripts. You only do that in covalent. So magnesium is +2, oxygen's -2, MgO, and that is magnesium oxide. All right, calcium is a +2, nitrogen is a -3. So I'm going to end up with Ca3N2, calcium nitride. Aluminum is +3, bromine is -1, so that will give me Al1Br3, aluminum bromide. Okay, Be is beryllium, that is +2. Iodine is -1, so that leaves me with Be1I2, and that is beryllium iodide. All right, barium is a +2. Phosphorus is a -3. So I'm going to end up with Ba3P2. That is barium, and that would become phosphide. Okay, potassium is a +1, and sulfur is a -2. So I will end up with K2S1, potassium sulfide. All right, magnesium +2, bromine -1. So I will end up with an Mg1Br2, which is magnesium bromide. Okay, this one down here, potassium nitride, and we have to put the formula. So potassium, I always do potassium and nitrogen. I'm going to go over here and I'm going to get their oxidation numbers. Potassium is a +1. Nitrogen is a -3. So it's going to be K3N1. I would crisscross those down. Barium chloride is a BaCl. Barium is a +2, and chlorine is a -1. Crisscross, I'll end up with that. Magnesium sulfide is magnesium and sulfur. Magnesium is a +2, sulfur is a -2. Those balance, 2 and 2 would reduce to 1 to 1. Lithium oxide, lithium is Li, oxygen is O, lithium has a +1, oxygen has a -2. So I would end up with Li2O. And there's that side. If you need more practice, we're going to flip over to the back. It says, look at each pair of compound or elements below and circle any pair of elements that will bond to each other to form an ionic bond. So if we're looking for ionic bonds, we're looking for a metal and a non-metal. So chlorine and bromine, that would not be because chlorine and bromine are both nonmetals. Potassium and helium, that will not. Helium's a noble gas. It's not going to bond with anything. Beryllium and magnesium. Beryllium is a metal. Magnesium is also a metal. That will not make an ionic bond. Sodium and fluorine. Sodium's a metal. Fluorine's a nonmetal. That will make one. Calcium and potassium. Calcium and potassium are both metals. Not going to work. Oxygen and lithium, they will work because lithium is your metal, oxygen's your nonmetal. Lithium and chlorine, that would work because lithium's the metal, chlorine's the nonmetal. Iodine and sodium would also work. Iodine and sodium. It doesn't say, normally the metal comes first, but it doesn't tell me that they have to be in that order. Nitrogen and oxygen, both nonmetals, not going to work. Calcium and iodine, it would work. Calcium's your metal, iodine's your nonmetal. Magnesium and neon, not going to work. Neon's a noble gas. And sodium and lithium will not work because they are both metals. All right, and 8 characteristics of ionic compounds. Those were kind of from before. Remember, ionic compounds, they're a metal and a nonmetal. Okay. They're metal and not a nonmetal. The metal gives the electron to the nonmetal. That's a characteristic. Because these are metals, they have high melting and boiling points. They are good conductors. They, my mind just went blank. They are good conductors of heat and electricity, right? Let's see, what else? They are crystalline in structure. They're crystalline. They are brittle and hard. They are soluble in water. And the very last one is, let me think, soluble in water. I just had it. They release hydrogens, electrolytes. That was my other one. Okay. And those were discussed on your section 2. The properties, I think it's section 2, section 3, learning target 3, ionic and covalent compounds, when we went over those. All right, so the very last portion here, the formula, sodium bromide. Sodium bromide. And again, you have to think, sodium's a +1, bromine's a -1. That works out perfect. Calcium chloride. Calcium is a +2, chlorine is a -1, so it'd be Ca2Cl. Magnesium sulfide is magnesium and sulfur. Magnesium is a +2, sulfur is a -2, so those equal out. Aluminum oxide, aluminum is a +3 and oxygen is a -2, so you're going to crisscross applesauce. Lithium phosphide, lithium is a +1, phosphorus is a -3, so you're going to end up with Li3P. Cesium nitride is cesium, which is Cs, and nitride is nitrogen. Cesium has, where is cesium? It has a +1 and nitrogen has a -3. So you're going to end up with CS3N1. Potassium iodide, Ki. So potassium has a +1, iodine has a -1. They are just fine the way that they are. Barium fluoride is Ba. Barium has +2. Fluorine has a -1, so the fluorine's going to have 2. Barium have 1. Rubidium nitride, rubidium here, nitrogen is there. Nitrogen has a -3, rubidium has a +1. So we got to put the 3 there. Barium oxide, barium and oxygen. Barium has a +2, oxygen has a -2, so you're done. This one here, potassium oxide. All you have to do, remember, for ionic is just call your elements. You don't worry about the subscript. You only worry about the subscript in the name if it's covalent. This is magnesium iodide, aluminum chloride, calcium, bromide, sodium, nitride, lithium, fluoride, barium, phosphide, cesium. I think cesium. I think I just misspelled that. I think it just has one S. Yes, C-E-S-I-U-M. Sulfide, strontium, and that is fluoride, and sodium chloride. And we're done. All right. If you have any questions, concerns, see me. I'm right here.